Hey again, guys, and welcome back. Today I want to take a look at these things. These are PIR, passive infrared sensors. Basically, what they do is you give them power and ground, and they grab an sort of an image of the infrared radiation coming into them, and then when there's a change in that infrared radiation, like let's say from the heat of our hands or our beings just walking in front of these, they will trigger one of the pins here to go high. And you can use that high trigger to do all sorts of things like turn on lights, activate relays, etc. And I have actually a project coming up before Halloween, I'm hoping. So in the next week or so, I want to use a PIR for it, but in order to do that, I have to figure out how they work. Now, if you don't know how they work, follow along with me. We're going to figure it out together. But Big Clive also has a video on these. It's a little bit old now, but I mean, there's no such thing as a bad Big Clive video. So just check it up in the card up there. So, first things first, operating range. These things can go as low as 5 volts, some go a little bit lower, and the listings say up to 20 volts. I don't know if I would go up to 20 volts, but we're going to try it at 5 volts today because, well, that's just about the kind of voltage I'll be working with. Now, these are the pins here. This is a jumper for another reason. This bigger guy here has actually sensitivity and time adjustment, like delay adjustment, how long it'll stay on for. This one here does not. It is a lot more simple and it's tiny. So if this one works for my application, I would rather use this one. If not, I'll go with this guy. So I guess next thing is to figure it out. So got my power supply over here, 5 volts. Got a breadboard here. And I'm guessing I want to point the sensor out that way because I'm standing over here, so I don't want it to get confused. So I guess what I'll do is I'll plug this in this way, like this, and then I'll get some extenders to extend this guy off the board. So let's see, these are female to female, male to female, that's what I need. Alright, so we're going to have power ground. Let's see, we'll grab power here. So I guess we need to power it directly like this. Ground. I always take out the red and the black ones and then I lose them because they're in other projects. So power and ground. And now I'm going to look onto here. There's a little negative sign, a little positive sign here, so the middle must be the output. Yeah, see, negative, positive, output. I don't know if you can see that too well, but it does say negative, out, and then plus. So the plus will be up here. And negative down here. Come on. There we go. Okay, positive, negative is done. Maybe I can stick this down too. The piece of sticky tack. Right on the hat here. By the way, this is just a cover with lensing. If you want to see what it really looks like, it looks like that. Apparently you're not supposed to touch these. And this lens is indexed. If you can see little grooves there, they fit onto a little pip on the metal bit. There we go. Okay, stick this down and stick this down. It's not really sticking very well. There we go. Okay, it's facing over there now. That should be okay. Can even stick down the breadboard somewhere over here. There we go. Should be fine. All right. Now I need a I need a load, I guess. So Big Clive was saying not to run a load directly from this, but I think for testing purposes it'll be okay. I have my quick access box over here, and I will grab an LED with a resistor already on it. Okay, so it'll go high, so I need to put the negative into ground. So the negative is the portion without the resistor, and I need a male-to-male jumper for that. So let's go white. So this guy to ground. I don't know how much voltage comes out of this, but hopefully it's enough to turn on the LED. And then I'll grab white for the signal here to positive and to the center pin. Shouldn't have stuck it down already. Okay, well, not sure what to expect, so let's go. Okay, so far I have 5 volts here. No current at all. I wouldn't even know if this is working. Oh, just triggered on. I didn't do anything. Let me give it a second here. I'm not sure where it's picking up its infrared from. Really doesn't look like it's turning off. Interesting. Turn it off again. Turn it on. It's directly on this time. Interesting. What if I spin it around like that? It's on again. That's interesting. I can't get it to turn off, and even if I go in front of it, I can't get it to turn on if it was reverse logic. Interesting. Maybe I should bring it up above the bench a little bit. So hopefully the sticky tack hasn't become conductive over time. I don't think so. Okay, let's prop it up. I have a battery charger here because I was charging batteries earlier today. Let me just stick this up like that. Right, well, I'll pause the camera here. I'll walk away from this and see if it turns on. And once I figure that out, I will bring you right back. So I am back, and I have noticed something pretty cool. So this, of course, is a switching power supply, and a lot of you have given me crap over using a switching power supply, but typically it's not a big deal. Usually it works just fine, and here I'll show you. The light is off, and there the light is on. Now we can just wait a short delay, and we will see that the light will turn off, like right there. But let me show you something interesting. If I play with these wires here, see how it triggered again? There was a slight drop in voltage, which caused by these dicky connections, but also caused by the sort of variability of this, the ripple of this power supply. So I have here a 470 microfarad cap, and I'll set that into the power rails. Actually, I'll set it a little bit closer to the wires, and now I can play with these wires, and they don't trigger the light anymore. It is now rock solid. So you can absolutely use a switching power supply like this to play with these PIRs, but since the voltage inside the voltage supply to this circuit is so minuscule, and sorry, I mean the voltage generated by the infrared light collected by the PIR sensor is so minuscule that even just the AC ripple of a power supply like this, especially when it's drawing no current trying to run this little LED, yeah, it's so sensitive that the ripple causes this to actually fail. It triggers it. So right now I can play with the wires as much as I want, and that's not triggering. In fact, even shaking the PIR is not making it trigger. But see, I put my hand anywhere within this sort of 180-degree field, and it does trigger. So a small little 470 microfarad cap is really all I needed, but I might add a couple to my project just to increase that stability. My project might also be run by batteries. I'm not sure yet, but this is why we prototype, because we can figure out issues like this quite simply. So that's awesome. I learned something today, and hopefully so did you. Now, on to this guy. So this guy has the same 3 pins, except they were covered. Couldn't see what they were saying. There's a little scratch on that. I hope that doesn't affect anything. VCC out and ground. So VCC is actually over on this side here. So I will turn this off like so. And I will grab these pins like that. VCC is over on this side. VCC just means positive. Don't worry about that. VCC over here. Out is in the middle. And ground is at the other end there. Now this one has sensitivity and let's just open this up again. It has sensitivity and it has delay, but I'm not seeing any markings on which is which. So we'll have to figure that out ourselves. Let me just grab all the sticky tack that's stuck to this PIR sensor here. So PIR, as far as I know, means passive infrared. I believe so. You can correct me in the video description or in the comments below if you'd like. I'm going to stick a blob on here and stick that on there. And give it a go. Alright, lights on. I'm going to stay still. Not sure if this is going to turn off or if we have a different issue with this. It also has a much larger globe, so I'm afraid that my studio lights up above that way will actually be triggering it. Not sure if we have a crappy connection again. It is possible these wires are no good. Okay, well, I can't be using my cognitive load to figure out whether it's my setup or this thing. So let me reconfigure some things and I will bring you right back. So I've changed these 2 wires with just a solid core phone wire. So that should be fine actually. But this PIR sensor does act a little weird. I went in front of it there and it just turned on. I put the delay really slow. It seems like if you go too fast, or sometimes it just won't trigger. It takes a little bit. There's sort of like a delay when it's off. Like it'll stay off for an extended period. See, now it won't go, but now it will. So I wonder if one of these is actually setting a time up where you can't re-trigger it before a certain amount of time. So this, let's say, this one here, that's definitely the time delay one, because look how much longer it's staying on. It's still on? Yeah, it's still on. Stays on for an absolute eternity. And I don't believe I've re-triggered it. I kept my hands sort of over here. It's still on. Yeah, I don't know what's going on with this one. If I turn the delay back down that way, it has a little bit of a refractory period and then it'll start working again. I wonder, yeah. I'm going to try here, see if that's a little bit longer, because now it's just a little bit tweaked up from the minimum. Now you see it stays on very long. I wonder what the time delay is. That's a lot. It's really long. I don't know if I can re-trigger it either. If I move this all the way this way, should turn off. Yeah, it turns off pretty quick. See, it won't go. Now it's turned on again. And off right away. If I change this jumper up to here, now it should be re-triggerable. So if I go sort of like this, and then I keep going, no, you see, it doesn't really, it still waits a while, and then it goes off. I wonder what's doing that. Let's turn this guy, which I think is a sensitivity, to the other end, and now look, same kind of deal. Go a little bit further with it. I mean, it's my hand. It should have some sort of... I now just triggered and I wasn't even in front of it. Alright, let me do some reading, and I'll be right back. Aha. So, a little bit of reading, and this module is actually a copy, a clone, of the Adafruit PIR module. So it's using the same BIS 0001 chip on it. The time and the sensitivity are these two pots for sure, but it's laid out a little differently than in the Adafruit, but it does seem like the maximum amount of time is clockwise, so this one's definitely set to the minimum. That would be the time, and this is the sensitivity, and max sensitivity would be all the way clockwise. So minimum time, maximum sensitivity right now. There is also a setting that doesn't allow this to be re-triggered one more time, and that's not easily changeable because it is part of a resistor network on the board. So I can't change that. So there should be approximately a 2.5 second delay before it can get re-triggered. So that's pretty good. So there's the delay, and the only thing is I should be able to continuously trigger it depending on the position of this jumper. So I'm going to move that down and see if it works for constant re-triggering. Another thing to note is you have to give 30 seconds to 60 seconds to these sensors to stabilize. So before they are stable, they will take some time. And if you look here, you see that? I'm re-triggering this without it turning off because I'm still moving in front of it. And as soon as I move away, it should turn off. So like this, it'll do its little time delay and stop. 2.5 seconds later, I should be able to re-trigger this. So it should be ready now. And I believe I'm reflecting some of my infrared off this glass here. But yeah, so this moving around like this should be making it stay on, which it does. and then I move away, it should turn off, and I think 2.5 seconds later, it should be ready to go. There it goes again. So it's very sensitive. I do have it at the max sensitivity, mind you, but that's good. That is completely fine. And now I know how to work these two sensors, and I can pick one and go ahead with the project. So I hope you guys pick one up yourselves. These are about $1.50 American, about $2 Canadian online. Some of these are actually 99 cents. I think this little guy is cheaper than this big guy. It would make sense. I would say pick yourself up a few and have some fun. But this video is just a little example on how we can get it to work. I think I will make another video showing how to hook this up to bigger loads. Thanks again for watching.